Hi, and thank you so much for joining us today on Building Intelligent Apps in the Cloud with Azure. I'm Michelle McLean, VP of Marketing at ScaleArc, and I'm joined today by Ahmed Farag, who will be taking us through an overview of how to do app dev in Azure. Obviously, he can't boil the ocean and cover everything, but he's going to take a little slice of it. We'll go through that discussion. He'll share a demo. And then I'll step back in and share a little bit about the Microsoft ScaleArc partnership in more detail. So, Ahmed, go ahead and take it away.
Perfect. Thank you, Michelle. So what we're going to talk about today is developing apps, intelligent apps on the cloud. And before we do that, I wanted to discuss all the different flavors of cloud services that we have today. So if you look at the cloud services that we have, specifically on Azure, we provide you the ability to build what we call applications on IaaS, infrastructure as a service. And you also can build your applications on platform as a service, or you can build your applications on software as a service. And traditionally, before the revolution of clouds, before AWS and Microsoft and Google start building their cloud services, customers used to build their applications on-premise, and that's represented on the column at the very last end on the left side. This blue column represents all the different things that a developer or an application owner has to take care of for building and hosting application on-premise. They have to, make sure they have the infrastructure to support that application. They have to obviously build their application, make sure they have, appropriate location for storing the data, runtime, maintaining the OS, and patching. With the revolution of cloud, now you can deploy your applications on infrastructure as a service, which basically having a cloud provider like Microsoft Azure take care of all the infrastructure, the physical infrastructure, but underneath your application that basically starts with the virtualization layer, so provide you with a hypervisor that hosts your OS, and also provide the servers and the storage and the networking that will provide all the capability for your application to run. So infrastructure as a service is a good choice if you have applications that need to be hosted on the cloud, but you don't really want to worry about having to maintain the actual physical infrastructure. But then if you have an application that can really be deployed on the platform as a service, an application that essentially is just your code and data, you can go with platform as a service, and in that case, the cloud provider will take care of OS, the OS patching, the OS upgrades, as well as the runtime and the middleware for you. So that will be represented on the path column. And if you only have data and you have a specific application that's already hosted on the cloud on a hosted environment, that's what we call software as a service. An example of that would be Exchange Online or SharePoint Online. You can definitely choose software as a service, and that's not going to require you to write any code. All you have to do is just basically create a subscription and then configure the tenant or the subscription with your information. So what we're going to talk about today, we're going to focus more on paths, and we're going to show you how you can quickly build an application in the cloud, yet have control on defining how your application is going to perform, integrate with different systems, and don't really write code. So we're going to show you how you can do this with no code, and how you can do this in a very short time. And before we do that, the reason that customers started looking into paths is because the time to provide a solution to market and provide value is really much faster than IaaS. So through that chart, you can see paths will really unlock the ability to provide more innovation and go to market much faster. So it's really more efficient. So if you really don't require access all the way to the OS level, so you have, for example, DLLs and assemblies that requires you to remote to the machine, or RDP, or SSH to the Linux box and do configurations on the OS level, we do recommend you to look at a path platform that will fit your needs. This way, you really accelerate the production or getting your application out to customers. And Forrester did a good study on path services in Azure, and they found that there is a huge return of investment when you go to paths versus going to IaaS. So you can see the numbers here. we can do almost like 400% more return of investment if you go with paths. You can save a lot of money, and you can save about 80% of time when you build your application using paths. You also have the ability to release your application faster, almost 50% faster. So with that said, I would like to scope this discussion today about one of the platform as a service services that we have in Azure. It's called Microsoft Logic Apps, and talk about how Logic Apps can achieve a lot of those things. So we're going to talk about Logic Apps, and Logic Apps is basically a platform in Azure, part of our platform as a service suite that allows you to connect different systems together. It also allows you to perform actions, and it has the ability to build workflows and orchestration. So when we talk about workflows, we're talking about activities that involves human. So humans often respond, in different times. So you can have a person respond to, for example, a workflow, an approval workflow within an hour, or maybe they're not available at that day when you submitted the approval request. So they will respond to it, the next day. So they can respond within days, weeks, or they can respond instantly. So those workflows require a platform to be, aware of time, and it can persist the information of the status of your application, across days, and be able to rehydrate that information whenever the user is available to interact back with the application. Logic App also allows you to do orchestration between different processes. So you can have one process in one application, let's say an Oracle database, and another process in another application, let's say a Salesforce instance. And those two different systems, they would like to interact together, maybe share account information or push data or synchronize records. And this orchestration can be done using Logic Apps, and it can be done without having to write code. And this is only doable because we have built a set of connectors for a lot of the popular applications that we have today. So I think we have about more than 200 different connectors that allows you to choose what applications that you want to connect to without having to write code. And then we provide you a common set of actions that you can perform, and also you can include them in a workflow. So a Logic App is really an event-driven application that you can define in Azure. It's completely serverless, so you don't really have to define what servers this app is going to run on. Everything happens for you behind the scenes. So we have enterprise scale monitoring in the platform that will detect how much load your application is generating, and then it will roll out servers behind the scenes for you. So it's completely transparent from you. You have to really focus on your application and your application logic more than think about any infrastructure requirements. And for that, getting those applications out is much easier, so you can really get them out much faster. So it's really rapid development. It lets you really focus on your business logic as opposed to waste your time on infrastructure. And because you don't really write a lot of code, or you don't really write code at all, it really reduces the risks of having bugs and issues, because those are pre-written modules, pre-tested by millions of users. So it reduces the cost of testing applications and fixing bugs as well. And the way we charge for that service is really by action. And this is one of the popular things that customers like about Logic Apps, because think of this traditionally. If you have a co-location in a data center where you have multiple servers that host your application, you're going to pay the lease for those server that in that location, that for whatever it is, a cage or multiple racks. So you're going to pay, with a yearly contract or a monthly contract, and you'll pay that money even if your application is not used. So if your application is sitting, for example, from January to April, not being utilized, you still have to pay for that lease. However, with the Logic App, you can create your app and you can have it hosted in Azure, and we only going to charge you whenever an action is done, whenever it creates and produces results. So it's really action-driven, it really makes sense for customers who really want to control their cost to use a serverless technology like Logic Apps. So we talked a lot about Logic Apps. I'd like to show you kind of an overview of how how it really works. In this diagram, you can see Logic App is represented, in that icon in the middle, the blue-green icon Logic App. And it really is a way for you to define a set of actions in a workflow. And on the right side, we have examples of those different systems that we can integrate with. And those systems can be the trigger for my app, or they can be the systems that I will perform action at. So I can, for example, listen, on a Dropbox folder. I can send a message to a Slack channel. I can, pick up an account from a Salesforce instance, or I can connect to Workday. So all these are different, services that we integrate with, including ServiceNow and so on. We have about 200 or more than 200 of those in the system. So those are third-party. Most of them are third-party applications. They're not Microsoft applications or systems. But however, we definitely integrate with all the Microsoft services that we have today, including Azure. So at the very top, you can see a list of, our cognitive services in Azure. Those are services that you can use to perform, tasks that require machine learning and artificial intelligence, things like facial recognition, OCR, vision analysis, and so on. And we're going to see an example of that in our demo. On the left side, you can see a list of services that we support in Azure today. So if you have a need to integrate with Azure Active Directory to, provide authentication in your application, this is something you can definitely do, and it's seamless through the Logic App. We don't really stop there. We also allow you to connect to on-premise systems. So we have something called on-premise data gateway that's represented in the bottom with the dark blue cloud, and this allows you to bridge and connect to systems on-premise, not only publicly available applications like ServiceNow and Workday and Salesforce. We also can connect to your local database in your data center using that gateway. So you can connect to SQL Server, SAP instances, you can connect to Oracle databases and IBM databases. And we're going to continue to add more and more services that we allow you to connect to on-premise. So a Logic App can work as a central application that will connect all these different systems, whether they are on-premise or in the cloud, in a single application without having to write code. So with that, I'd like to jump to a demo and show you how this works in an action. So I'm going to go ahead and switch to my browser. And what you see here is essentially the Azure portal. So if you're not familiar with this, this is the portal where you can create resources in Azure. And those resources can be virtual machines, virtual networks, and obviously can be also SQL Server. And in our case, we're going to create a Logic App. How do you go to the portal? You go to portal.azure.com. So portal.azure.com is going to take you to this experience. If you don't have an account, it'll let you create a free trial for $200 credit, where you can try resources in Azure without any restrictions. So right now I'm logged into my account, and I am at portal.azure.com. I'm going to go ahead and create a new resource, and that resource is going to be a Logic App. So I'm going to search for Logic App, and this is going to show me all the different, applications that Logic App supports here. So I have Logic App. That's what I want to create. It's created by Microsoft. You can see we have third-party applications on Azure in the marketplace. Some of them are not created by Microsoft, as you see here, and you can choose whichever suits you. In our case, we want to create a Logic App, so I'm going to select Logic App and click Create. So what this is going to take me, it's going to ask me to provide a name for the Logic App, and I'm going to give it a name, Arc Demo, and I'll put this in my subscription, and then I'm going to use an existing group. So this is just to organize things. I do have a group created for this demo. I'm going to call it Logic. And you can choose which data center you want your application to reside at. This defines the region, the country. So we have Australia, Japan, Canada, India, and so many different locations. We have 42 different locations in the world. This is the most number of data centers across all different cloud providers. So I'm going to click Create, and what this is going to do, it's going to spin for a few seconds, and it will create an empty canvas for me to start building my Logic App. And after that canvas is created, I can go ahead and start designing my app using a designer in the browser. So now it's done. I'm going to click on Go to Resources. And that's going to take me to my empty Logic App canvas, and I can go to the designer directly. So this is the kind of designer quick start guide, and what it shows you here, there is a video that you can watch that tells you how you can start use that Logic App. So each Logic App starts with a trigger. So a trigger can be a schedule. So you can set a recurring schedule that says run my app every Sunday of every week. Or whatever schedule suits you. Or it can also be, for example, listening on a specific FTP server, listening on a file server, listening on OneDrive, on Dropbox, so listening on something. It can be also looking for a specific tweet. It can be programmatically invoked. So it can be programmatically invoked through an HTTP request or a web API request. So you can call it from your own app. So these are all examples of triggers, but not everything. So I'm going to choose to go with a blank Logic App. We already have several templates that can get you started quickly. So, for example, we have a template to listen on a Dropbox and then copy a file from Dropbox to OneDrive. We have another example where we copy a Salesforce account to a database. So all those are predefined templates that you can use that get you started really quickly. I'm going to go ahead and choose the blank Logic App. And in this demo, I'd like to show you how we can listen on a OneDrive folder for any pictures. And once the picture is uploaded, I'm going to go ahead and take that picture and do an OCR to convert the text in that picture to an actual text that we can read, and then send that out through email. So the first step is to basically listen on OneDrive. So in that case, my trigger is going to be OneDrive. So I'm going to select OneDrive. And it's going to ask me what kind of trigger that you want to use. Is it when the file is created? So that's going to be the one that I'm going to choose. I can also choose to have this trigger when the file is modified. I'm going to choose when a file is created. So the next step would be to provide your credentials, and I've already done that. So I already have a connection here with my personal account, so I'm not going to do that. And then I'm going to specify that I'd like to make sure this runs every 30 seconds maximum. So keep checking on that folder every 30 seconds. And I don't want this to listen to the root folder, so I'm going to choose a specific folder. So I'm going to click here, and then I'm going to navigate to the pictures folder. And then the next step would be to add an action. So the action in this case is OCR. So I'm going to look through all these different connectors that we have with all these different services. We have 289 connectors. We're close to 300. So I'm going to search for OCR, and that's going to bring all the results of the OCR functionality that we have. So we have OCR to text. So I'm going to go with that option. And then all I have to do is specify how the image is going to come. So in our case, it's going to be the actual image content that we pick up from the OneDrive file. So I'm going to go ahead and choose image content. And then dynamically here, I just need to drag and drop the file content that comes from the previous step. Now this is all set. All I have to do now is send the email. So I'm just going to go look for outlook.com, and that's going to choose the outlook.com connector where I can send an email. Again, I've already created a connection for that, so all I have to do is just click the action, which is send an email. And in this email, I'm going to choose to send the file. So the address here is going to be my Microsoft account, and the subject is going to be the file name. So I'm going to use file name as the subject. And the body here, I can type something. This is the text detected in the picture. And then I will grab the detected text from the previous step, which is the OCR. Now this is done. I just need to save it and then run it. And then what I'm going to do, while it's waiting for a file to be uploaded, I'm going to use my phone using the Office Link application to take a picture of a calendar that sits on my desk right now, and then have that sent to the OneDrive where we pick it up and then do the OCR. So the picture is taken, and bear with me, you don't see this because I'm not sharing my iPhone screen, but once I save the file, it'll just show up inside the viewer. So now the file is uploaded. What you're going to see here is the file showing up in OneDrive, and then the OCR picking up the file. So the file has arrived, then the OCR has picked it up, and we can also see the output here. So you can see the output for a few words that it detected: quake guide, building emergency response plan, and so all those text was in the picture, and then it sent the email. So now I can go and check my my email, and I should be able to see the email. And I probably should just refresh my email here really quickly. I'll just reconnect my email. And then once my Outlook is connected, I should be able to see that email being received. And what happened here, we executed 3 steps. We listened on the folder, the picture was sent, and then the OCR has been done, and then the email is sent. So now that my email is updating, I can go and check here, and I can see the picture has been received here, and all the text that has been detected in there. So and the picture is attached as well. So this is just basically a demo of taking a picture and having the picture sent through Logic app, and having that picture, OCR'd and the text sent to through email. So with that, I want to close this by, give it a try. We do have a list, go-to actions here. So if you want to try it out, just go to aka.ms/logicapps-docs or aka.ms/logicapps-blog. And with that, I'd like to turn it back to Michelle.
Fantastic. That was a great demo, Ahmed. That really brings it to life and shows the simplicity. I'm going to come in here and share presentation. So let me go in here and launch this. So Microsoft and ScaleArc have been partners for quite some time, the rapidly evolving world of Azure is a great example of the power of our partnership. Our software works with a variety of Microsoft platforms, data-based platforms, in particular on-prem or in the cloud. And what we're looking to do is, when you're getting into Azure or when you're running in Azure, we're looking to make all of that simpler and make performance for your applications have better availability and better performance. So the application that Ahmed just built, once you're running in Azure, we could be complementing that application to improve its performance and uptime. So how do we do that? Our software is basically an abstraction layer that sits between your app tier and your data tier. And this gets particularly interesting when you think about cloud deployments, right? So instead of directly connecting apps to the database, now you're running through our middleware, if you will, that's sitting between the two and intelligently directing the traffic into the database servers. So on-prem, this is really straightforward. We sit on our own VM or our own server, front-ending the servers. And in the cloud, it gets very interesting. It could be hybrid. You could have data on-prem and your apps in the cloud, in which case we would sit close to the apps because we also have some performance enhancements like caching that work better when we sit close to the app. Or you could be fully in the cloud, in which case you deploy on Azure through the marketplace in conjunction with SQL Server on IaaS, or in conjunction with Azure SQL DB, for example, on a PaaS offering. Slightly different from what Ahmed just showed, but again, we work in both the IaaS and PaaS worlds and complement those offerings. So what is it that we provide and how do we do it? So the first thing is that for a lot of customers, moving workloads, particularly critical workloads, to Azure, for some data workloads, it's the first time perhaps that customer has needed to scale out that database. They might have had one big honkin' server on-prem, and that's just not pragmatic in the cloud. You want that linear elasticity of Azure, and you can get that with cloud services, but how do you get your app to tap into it, right? And so it's unveiling and making that elasticity available at the app tier where ScaleArc really shines. So you can adopt modern database technology on-prem or in the cloud, get that linear scale out without making application code changes. So it's one of the reasons that Microsoft and ScaleArc have become such tight partners. The other thing is that that scale out in Azure can be particularly challenging when you're looking to do cross-region deployments and you're trying to be deliberate about where you're placing different resources. So Ahmed showed you that you can pick the region that you're sitting in. You can do that in a lot of their services. And so ScaleArc is a layer of technology that can help you straddle multiple Azure regions and improve the failover between those regions on the various cloud services. So a big part of our value is enabling continuous availability regardless of what happens at the data tier. Because of where we sit and the fact that we're handling the traffic into those database servers, we can avoid downtime at the application layer, even if you have downtime at the data layer. And I'll show you that in a second. And then with the connection management and caching capabilities that we have that, again, require no application code changes, your apps, your websites, et cetera, can go much faster. So what purpose does this serve? What are people using ScaleArc to do? So the first three use cases you see there are all about getting into the cloud, right? So making existing workloads migrate faster and easier, building new workloads like Ahmed just demonstrated, and then enhancing what's going on in DBaaS. DBaaS is really sophisticated, right? A service like Azure SQL DB is super sophisticated. However, there's still a challenge when the app is directly connected to the data resource. With our abstraction layer, we can enhance how that DBaaS platform serves the app. Enabling continuous availability, which I'll step through in a packet fashion in a minute here. And as part of that, enabling active-active architectures. We see a lot of folks looking to do this, whether it's still a data center application or they're looking to run in multiple regions. Like Ahmed was showing you, you can choose to run in active-active mode straddling multiple regions. And then we touched on increasing the performance, scaling with no code changes, and speeding up your move to modern SQL. So what does this failover look like in operation? So this could be an accidental outage, or you could even have this kind of activity triggered on purpose because you want to do zero downtime maintenance. So let's look at it in operation. ScaleArc, sitting where it sits, detects reads versus writes and sends them to the appropriate servers. So the first time you're using secondaries, for example, readable secondaries, you can do that without adding read intent strings to the app. We're going to do that read-write split automatically on behalf of the app. Now let's say we're constantly monitoring the status. We're doing this whether it's SQL Server on IaaS or whether it's Azure SQL DB. We're constantly monitoring the status of all the servers in the cluster that the app's talking to. We recognize if anything goes wrong with that primary. So if we see that that's going down and we recognize that the secondary is going to be promoted, we immediately invoke a queue. We hold the writes in that queue, waiting for the secondary to be ready, and we keep sending the reads to the unimpacted secondaries. So with most applications, they're majority read versus write. Those services will continue to run because we're not losing all those connections because we're sitting between the app tier and the data tier. And then once that secondary is ready, and it's become the new primary, we drain our queue in a FIFO manner, preserving data integrity, and now we continue doing the read-write split across all the available resources. And if that other server comes back, it might be in a secondary role, we recognize that, or you might want to flip back to having that be primary. You've got all sorts of choices. But the upshot here is that because we're aware of the status, because we're holding the traffic, your applications see an outage as just a little bit of delay instead of getting flooded with errors. And most applications handle that much, much better. So if you look at this in more detail in a cloud environment, again, supporting lots of different modes, right? It could be cross-geo, it could be hybrid, it could be fully in Azure. We're going to do that read-write split. We're going to geo-load balance that traffic. So we will keep reads local whenever possible. And how do we do that? We're constantly monitoring for time to first byte. So we're going to send your traffic to the fastest performing server. So whatever might be going on, or if a region becomes stressed and isn't servicing traffic as well, we're going to relay that traffic dynamically based on time to first byte. We're also going to avoid any servers that have fallen behind in terms of replication. So we are always monitoring replication lag, and we won't serve stale data. So we will take that server out of rotation as a read server until it's been able to catch up and is up to date on replication status. And then with the ability to do the connection management and in particular app transparent caching, our customers in the cloud have seen much, much faster performance. So again, if you're able to cache a response, particularly for hybrid deployments where the data is on-prem and the app's in the cloud, if you're able to cache some of that data, you're no longer having to traverse that WAN hop for serving that reply. We're going to do that automatically, and you keep that cache clean by either having it expire at a certain time or having it auto-expire if the data changes or is updated. So quick snapshot on a joint customer success story. NHS Choices, the biggest federal agency in the world, they run everything in Azure, and they run the access to all of your doctor's information. This is the National Healthcare Service for the UK. All of your signing up for doctors, looking up your health plans, all of your experience with the health plan as a consumer of that health plan happens on Azure, happens through ScaleArc. So they got to the scale that they wanted to get to and the elasticity that they wanted to get to by leveraging Azure, and pairing that with ScaleArc meant that they were able to do app transparent failover, do the scalability with no code changes, and really optimize performance. So we're doing this for a bunch of joint customers where, again, performance is critical, getting into the cloud is critical, and they just can't tolerate the downtime. So that's a quick snapshot of ScaleArc on Azure. Ahmed, I want to thank you so much for your time today and your demo. It was really well done, and I think made it very clear how easy it is to build intelligent apps in Azure today. So thank you so much for your time.
Perfect. Thanks, Michelle.
All right, and we hope to see you online on other resources in the future. Thank you so much, everybody.